Hello everybody. I have another example of how we can use Mohr circle for a given stress element, as you see here, uh, to find actually stresses at some other plane. So in this case, actually, the objective is to find these transformation stresses or stresses sigma x prime, sigma y prime, and tau x y prime at an angle of 45 degrees positive. Positive means going counterclockwise. So look at a plane, 45 degrees counterclockwise to point A, which is our reference basically. And you've already seen this example numerous times. We've already done this problem earlier using this transformation equation, as you can see here. And I can tell you what the answer should be actually, your sigma x prime, if you just plug in. And if you guys recall, the reason I use 45 degrees so we can quickly actually do the calculation, because 2 times 45 becomes 90 degrees, and cosine of 90 degrees is 0 and sine of 90 degrees is 1. So this is 0 in this term and this is 1. So you could just plug in the numbers. So we end up getting the following. Sigma x prime equals 60, tau x y prime becomes negative 30, and then sigma y prime, based on that invariant of the sum of normal stresses, should be equal to and a constant happens to be negative 20 megapascal. Okay, so we already have the answer. But how would you do this if you wanted to use Mohr circle? So again, in order to draw the Mohr circle, you've already seen this in the previous example, previous video, that we need to look at point A and the coordinates of point A, which would be sigma x. So our sigma x obviously is 50, our sigma y is negative 10, and our tau xy is a positive 40. Okay, so A has the coordinate of sigma x and tau xy, so 50 and 40. And remember, center of the circle has the coordinates of sigma average and 0. And you know that sigma average would be 20 and 0. Okay, so let me pause again and draw the circle and talk about that. Okay, so here's our circle. So positive sigma is to the right, positive tau is downward, and you locate the center, 20 and 0, and you locate point A, you connect C to A, you establish the radius, right? Here we go, that's your radius, and then you can draw your circle, right? As you could see, I'm just redrawing over the one that I've already drawn. So then let me just erase this little tiny thing and let's continue. Okay, so now you want to, by the way, you guys remember that 2 theta 1, which is the angle shown here, happens to be 56 based on the video that you've already seen. Remember, tangent 2 theta 1 was what? Tau xy. If you want to use the formula, of course, you could also figure that out just by doing the graphical approach. Anyways, so now I want to look at a plane that is 45 degrees to what I have counterclockwise. So you see point A now, which was here, now has moved here. Okay, so the question is, what is sigma x prime and tau x prime, y prime, and then sigma y prime? Remember, we already have the values based on the transformation equations. But how do we do it using Mohr circle? Very simple. You want to move point A from here to here. That is 45 degrees on the element. When it comes to Mohr circle, that becomes 2 theta or 90 degrees. So if you go 90 degrees, you'll end up here. That's your 90 degrees. So if this point A, now this is A prime. So what's the coordinate of point A prime? You could do that graphically very easy. You already know your R is 50, right? We've done that in the before, right? And then this angle is about then 24 degrees, or rather 34 degrees, sorry. You could also use the slope, by the way, guys. You could see that this slope of this guy is 4/3, right? So the slope of this guy must be what? 3/4, right? So either by the angle or by the slope. In any case, this is also the radius, which is 50. So your sigma x prime becomes this value of the center, which is sigma average, plus r cosine of this angle, right? R cosine of basically 34 degrees. It's not exactly 34 degrees. So if you do the calculation, so this is 20 plus 50 cosine 34 should be, 50 cosine 34 should be about 40, I believe. So you end up getting 60. So here we go. The coordinate of this point so far is 60. So right here you will have the 60. So 60 here. Then you could do the tau x prime y prime by saying, okay, this is the tau x prime y prime, right? Which is basically r, the hypotenuse, times sine of the angle. And so if you calculate that, the 50 sine 34, right? You should get 30, but remember we are on the negative side of the axis. So that would be negative 30. So here's the shear stress, negative 30. So once you figure out the direction of 30 for the shear stress, it would be the same on any other. And then, by the way, based on the fact that sigma x plus sigma y must be equal to sigma x prime plus sigma y prime, right? So a 50 minus a 10 must be what? 60 minus what? Minus 20. So sigma y prime should be 20. So negative. So a 20 here and a 20 here. By the way, on the diagram, that would be right here. So remember, between a prime, between this plane and this plane is 90 degrees or 180 degrees. So if you go 180 degrees, you end up here. So this is actually point, I don't know if you're going to call it B prime. If this was B, this would be B prime. There we go. So this is actually point B here, and this is B prime, which its coordinates should be exactly the same as minus 20 and positive 30. That's the shear stress. Okay, hopefully this made sense to you. It's the end result is very messy, but I'm sure you'll figure it out. Okay, thanks. This will conclude this chapter, and this is basically the last video for my Wentworth class, and for Northeastern we keep going. Thank you.